This video is about two variable equations. In the last video, we talked about one variable equations, but this time we're going to add in the second, so we have an input value and an output value. I'll let you read the problem. I'm pretty sure you can read, but I'm going to highlight what I think is some of the important information. And I always like to highlight and color code. Renting a tube costs a flat fee of $5 plus an additional $2 per hour. I think that's important. So number one, Maria started making a table that relates the number of hours a tube is rented to the cost of renting the tube. So we're going to figure out all this stuff. So if I rent it for 1 hour, I've got the $5 entry fee, and I've got the $2 rental fee per hour, so $7, right? And so for every hour I go after that, it's $2 more. So 7, 8, 9, 9, 10, 11, 11, 12, 13, 13, 14, 15. So explain how a customer could use the pattern in the table to determine the cost of running a tube for 6 hours. Seems to me like the easiest way would be to add $2 to the cost of 5 hours, because it's, we're just adding $2 more per hour. We've only got to pay that entry fee one time. All right, next, Maria wants to write an equation in two variables, x and y. Cool. What does the independent variable x represent? So the independent is the number of hours the tube is rented. And that's because the cost depends on the number of hours rented. So the dependent, or the y-axis, is cost. The independent, the x-axis, is going to be hours rented. Hours rented. Okay, and I think that probably answers the next question too. What does the dependent variable y represent? And that would be the total cost. And it's that because the total cost dependent on the number of hours rented. So the equation that models this situation, y, the total cost, equals that $5 entry fee plus $2 for every hour that we are at the park. Y equals 5 plus 2x. How can we tell whether this equation is written correctly? The easiest way would be to choose a value and plug it back into that table. I guess you could graph it and check it if you wanted to. Whatever your preference is. I'm going to go the easy way. I'm going to say 2 hours, right? So 2 hours would be 9, okay? 2 times 2 is 4. 4 plus 5 is 9. Checks out. Number 6, how can you tell... Oh, sorry. Geez, Mr. Clark. You're mine today. Explain how an employee could use the equation to determine how much to charge a customer. They should just be able to substitute the number of hours in and crank out the correct cost. That's pretty straightforward. All right, list 5 ordered pairs that lie on the graph of the relationship between x and y. All we have to do really is write down the ordered pairs from that table we had before. And I can't show previous page and this page on the screen at the same time. So I'm going to have the other page on my other monitor, and we're just going to write down those ordered pairs. Okay, so the first ordered pair was 1, 7. The second ordered pair was 2, 9. The third ordered pair was 3, 11. The fourth ordered pair was 4, 13. And the last ordered pair was 5, 15 for that table. Cool. Super easy. Number 9, use the grid below. Write an appropriate title for the graph. Oh, like that. Based on the real world situation. So we said our independent axis, our x, is going to be the number of hours rented. So let's go ahead and write hours rented. So number hours rented. My y-axis, the dependent. Why is it writing it down what I wrote? That's rude. The y-axis, the vertical, the dependent, we said was the total cost. in dollars. Cool. All right. I think that maybe a title could be tube rentals. Tube rentals. Does it say what this place was called? I guess you could say Sapphire Island Tube Rental, something like that, just so that we know what it's about. And then we're going to graph those delightful ordered pairs. So let's see. The first one was 1, 7. So 1, 7. The second is 2, 9. So 2 and going up to 9. 3, 11. 3 going up to 11. 4, 13. 4 to 13. And 5 to 15 were our official ordered pairs. All right, easy enough. So we can connect the dots. The ruler. That. And there we go. Now notice where our y-intercept is. That 5. What does that represent? That 5 is the entry fee. So even if I'm there for zero hours, walking in is going to cost me $5. All right, based on the graph, explain how you know whether the equation models the situation is a linear or is not a linear equation. Man, my reading is just weird today, isn't it? That's definitely a linear equation. The big giveaway here is that it is a straight line and has a constant rate of change. So either of those is okay. You can say straight line. The more appropriate is constant rate of change if you want to be super academic about it. Okay, so we'll say constant rate of change because I'm a good teacher. All right, reason quantitatively. Explain why the graph is only in the first quadrant. I want you to think about that for a second because we have 4 quadrants. So if it's in quadrant 1, it looks like this. Quadrant 2, think about our independent. Can you rent something for negative time? Unless you're, in a TARDIS or your Bill and Ted, that's not going to work out so well. So it can't be in quadrant 2 or quadrant 3 because the independent axis right there is going to be negative. Quadrant 4, will that work? Well, that's going to be a negative y value. And the last time I checked, places generally don't pay you to go places. Negative cost. So the only logical quadrant that this could be in would be the first. Okay, we already talked about number 12, the y-intercept of the graph. That's going to be the entry fee. Because if I walk through the gate, even if I walk right back out, I got to pay the $5. Okay. The next one is describe this. What is the slope of the graph? The slope of the graph is the rate of change, and the rate of change, which is attached to the x, is 2. The slope of the graph is 2, and in this case, it represents how much we're charging per hour to rent those tubes. So that will be the hourly cost. Hourly cost to rent tube. Number 14, work with your group. I guess that's kind of weird being virtual, isn't it? Describe plausible scenario related to a water park that could be modeled by the equation y equals 40x minus 8. Maybe. Whew. All right, so let's say that the water park sent $8 off coupons, and tickets to the park normally cost $40 each. If we want to keep in with our water park problem here, you could pick anything that you'd like. Whatever works for you. I think as long as it fits. Our rate of change is 40, and we're taking 8 away. I think a coupon probably makes the taking away make them